All right, so for this lesson, we're going to go over Tellegen's theorem. Tellegen's theorem is pretty simple for circuits. All it's saying is that, take what I've written here, power represented by P, and the elements for all the power, if you add them together, so sum of P, is always going to equal 0. And that's for all the elements in any circuit. And I use green here just to denote a negative P, and if it's negative power, then that means there is a supply of energy to that thing, or a supply of energy rather to the circuit. Something like that would be a voltage source. I used orange here to represent, so that means it's going to absorb the energy. And that could be resistors, LEDs, Arduino, it doesn't really matter. So now let's use that kind of base knowledge of Tellegen's theorem and use that to solve some just basic power in a really simple circuit. So let's say we're given this circuit. We have a voltage source of 24 volts. So I already know it's a voltage source, so it's going to be giving power. So you should already kind of be able to see that it's going to end up with a negative power value. We're given that the current is I equals 2 amps, and these are all in series, so everybody is going to have the exact same current. This is element number 1. We don't know what it is, we just know it's an element. We have it labeled 1. On this side, it's positive. This side, it's negative. So we're going from high potential to low potential. And then we have element number 2, high potential, low potential, 6 volts, 18 volts, respectively. So let's find the amount of power either coming or going from element number 1 and element number 2. And to do that, we're going to use our equation power equals current times voltage. P equals IV. All right, so let's do this for number 1. Number 1. So what's our power? Don't know. So say power equals our current, 2 amps, times our voltage, 6 volts. That's going to be 12. Of course, our unit for power is watts. Number 2. So we slide this up just a little bit. Number 2. Power is still going to be 2 amps times voltage, which is 18. And that, of course, 2 times 18 is going to be, let me put a V there. I'm a stickler for units. 2 times 18 is 36 watts. Now, your current, just to point out one detail, is going in this direction. It hits the positive sign first. So that means your 6 is positive. It's going to keep going in this direction. Hits the positive sign for the 18. So it's going to be positive. Now, current's going to keep going this way and go back up to what's obviously a voltage source, where it hits the negative before the positive. So let's do source. Power equals still 2 amps, because we're all in series. Now it's going to be times that negative 24 volts. All right, that of course is going to be negative 48 watts. So now here's the question. Is Tellegen's true in this situation? So sigma P, let me go over here instead. Make a little box. Sigma P equals 0. All right, so let's find out if that's true. So power from element 1 plus power from element 2 plus power in our voltage source should equal 0. So we have 12 watts. I just drew a 13. I don't know why in the world I did that. Ignore that. So we have 12 watts plus 36 watts plus, of course, it's going to be negative 48 watts. Put that in parentheses. All right. 12 plus 36, that's 48. Minus 48, of course, is 0 watts. So yes, that works. And that is just the down and dirty basic. How do you find power in elements of a circuit? Paying attention to these signs, gotta be very careful of that. And know that when you include all elements, including your voltage sources or any other source, that it's going to sum to 0 thanks to Tellegen's theorem. I hope you got something out of that. Have a great day. Subscribe, like, whatever you want to do. Comments are always welcomed, good and bad.